Now, this lecture on the preload and the afterload and see the effect of load on muscular contraction. In short, muscle contraction are of four types, but main is the isometric and isotonic. You must learn about the isometric and isotonic. Isometric means, as the name indicates, there is no change in the length, and isotonic means there is no change in the tension. So it is isotonic, and metric means length, measurement. So there is no change in the length. Now this is the quality of the muscle tendon, that it is an elastic tissue. So once it contracts, it has a capability to get back to its original state. So elasticity is the main point which we have to emphasize here, that it is present in the muscle tendon components. So for the mechanical point of view, or from a mechanical perspective, the musculotendinous unit behave as there are 2 points. You must remember, one is the contractile component and another is non-contractile component. The contractile component, all we know, is a contractile protein in the form of actin and myosin. But non-contractile component means elastic component are of 2 types. One is which is present in parallel to the contractile component, that is called PEC. P means parallel elastic component. What may be they are muscle membrane, epimysium, perimysium and endomysium. So these are the elastic components which are present in parallel. So it is, in short, is known as PEC. Another elastic component is present in series. Means muscle, you can presume the belly of the muscle and then the attachment of the tendon. You can presume yourself. In series, there is another elastic component that is known as series elastic component that is present in the tendon. So parallel elastic component or series elastic component, because of this, there is a what type of the behavior of the muscle is the elastic behavior of the muscle. So once we concerned with the PEC, means parallel elastic component, means membrane or myosium, then it will provide resistance when the muscle is passively stretched. It's important. It provides resistance, means they will not stretched. Now the series elastic component residing in the tendon act as a spring to store elastic energy when a tense muscle is stretched. So here the muscle has to be tense, not at a relaxed stage, and the muscle has to be stretched once it is tensed. So once it is a tense muscle is stretched, it will store spring to it act as a spring and store elastic. So development of the active tension is important to lift the weight or to do the work done, and it is proportionate to the cross bridges, number of the cross bridges which is formed. So the number of the cross bridges is responsible to the development of the active tension, you can say. So the active tension is always proportionate to the number of the cross bridges formed. So at the optimal length, maximum cross bridges are formed and muscle is stretched. When the muscle is stretched to greater length, or muscle is not stretched and its length is decreased, then there is no maximal overlapping of the actin and myosin filament. So optimal length, maximum cross bridges. When the muscle is of greater length, then number of the cross bridges is reduced and less overlapping between the actin and myosin filament. When the muscle length is decreased, then the thin filament colloid and tension is reduced. So there is a very much correlation between the length and the optimal length of the sarcomere. What do you mean by the optimal length of sarcomere? Between the length between the two Z lines in a skeletal muscle. It is important to know that with the optimum length, the maximal cross bridges between the actin and myosin filaments are formed. So by this curve, there are 4 points you must remember that A, B, C, D. They are the 4 points. In the A, this point, length is, sarcomere is this one, is 2 less. When it is 2 less, means this is the dark line, that is the actin filament. There is overlapping between the actin filaments, colloids, and the less cross bridges are formed here. So it is not a optimum length. Optimum length, here you can see in the B point, it is near to 2 micrometer, and this is the actin filament, this is myosin filament. There is a fair number of the cross bridges which are formed. In the same between the B and C you find the plateau, because up to this point, C point, there is maximal cross bridges developed, or you can say number of the cross bridges between the actin and myosin filament which is formed is the maximal. Now in the D point, when it is crosses the 3 and near to the 4 micrometer length of the sarcomere, there is overstretching and you will find no cross bridges between the actin and myosin filament. So the contraction of the sarcomere, contractile unit, depend upon the optimal length of the sarcomere. Now in this diagram, this is the contraction and this is isometric contraction, because the length cannot be shortened. Here the muscle belly and the tension, there is the 2 ends of the muscle which are fixed, and the lower end is fixed with the tension transducer, measuring transducer, force transducer. So during the contraction there is very slight thickening, but there is no uplifting of the load. Force is generated. When it relaxes, force is reduced, and the same stage, load position cannot be lifted and it remains in the same position. So during this contraction there is no work done. This is a very important point. Means this is the distance by which load is lifted. With this diagram it is very clear that why there is a difference between isometric and isotonic contraction, or you can say free-loaded and after-loaded. Now there are 3 primary components you must learn and already know that is a contractile component which contains contractile proteins in the form of actin and myosin filament. Now this is actin and this is the myosin. Now the optimal length of this contractile unit means sarcomere is very important, and it plays an important role to develop the force of contraction. But we are we are concerned with the tension which occur during the initial length. At initial length, or there are two components are very important. Series elastic component, in the rough diagram you can find out that it may be considered as a tendon, which one end of the tendon is attached to the bone, other end is attached to the muscle, and another is parallel elastic component, epimysium, perimysium in the form of endomysium, and fascia, which are in parallel to the muscle belly, means contractile muscle part. So there are two component, elastic component, series and parallel one. They play important role in the initial stages or initial length of the muscle. So once ever there is a contraction, these two parts they get contracted. But at the initial length, at the resting condition, once we apply the load, this series elastic component elongated. And the this offer parallel elastic component, this offers resistance during to elongate the length, and this is responsible to store the energy in the form of recoil. So the components are three. There are three functions different. So there is three different forces are developed which is responsible for changes in the isometric contraction and isotonic contraction. Now this model is explained. Both ends are fixed. In the first A picture, both ends are fixed. So once there is a contraction, it will not move the lever point. It will not move the lever point. So force generated by this isometric contraction, you will find no load or performance or work done is done. Here this end, tendon end is free, means applied to the load, and this end only one upper end is attached to the lever. Here you will find this free to move. But during contraction, as this part is free, this part is free, during contraction length can varies, tone increases, and there is a work done is here. So what is the basic difference? You now must learn in elaborate condition about the isometric and isotonic contraction. In isometric contraction means, as the name indicates, the muscle length is fixed. In isotonic contraction, the tone is fixed, tension is fixed. The muscle is stimulated to contract, and we develop the tension can be measured. So there is no shortening as the length is fixed. In isotonic, there is a shortening of the muscle fiber which can be measured. Now this is the example of isometric contraction can be show a very good relationship between the length and tension. So the length, initial length and tension developed. So at various length we measure the three tensions. Number one is passive tension, total tension and active tension. We find out the relationship between the length and tension. Passive tension, developed by stretching the muscles to different length. This always we give you example in the previous two diagrams. Now the total tension is developed when the muscle is stimulated to contract at different lengths, and active tension is a difference between the total tension and passive tension. Now very good example of isotonic contraction is force velocity relationship. What is the relationship between the force and velocity? So measures the velocity of shortening of isotonic contraction when the muscle is stimulated. So with a different afterload, load is applied against the muscle has to be contracted. So at different afterloads, we find out the velocity of the shortening. Now velocity of the shortening decreases as the load increases. So in the isometric contraction, you must learn about the three tensions: passive at the resting stage, total during the contraction, and when we minus the passive tension from the total tension, then the third one is active tension is generated. Now this active tension is responsible to lift the force or weight. Here in this x-axis, length is represented, and in y-axis the tension or weight is depicted. So there is a close relationship between the length and the tension. So there are three tension can be developed. Key terminology can be assigned to the tension. Then one is the passive, active or total. One here is the passive tension, means the tension which is exerted by the load at each length when it is not stimulated or at rest. So when the muscle length at rest and the load is applied, then it is a passive tension curve. Now, what do you mean by the total and active tension? The total curve, tension curve, represents tension developed when the muscle contracts isometrically and when we applied maximal stimulus. So maximal stimulus, isometric condition, and then the tension developed is known as total tension. And third terminology is active tension. If we deduct passive tension from the total tension, then it gives you active tension. Active tension, so it is a difference between the two, that is total tension minus passive tension is equal to. So there is a very well relationship between the length, tension, velocity of the contraction. When the muscle is stimulated to contract isometrically, then both total tension, passive tension exerted by unstimulated, unstimulated muscle vary with the length of the muscle fiber. And here the Frank-Starling law applies. Greater the initial length, resting length, greater would be the force of contraction. The length of the muscle can be varied by changing the distance between the two attachments. And length of the muscle at which active tension is maximal is usually called optimal resting length. For a sarcomere, it is 2.2 micrometer, 2 to 2.5 micrometer. Next slide. Now this curve shows relationship between the velocity and the load. X-axis load represent in kilograms, and on y-axis velocity of the contraction in centimeter per second. Now here the centimeter per second velocity is maximal here, but the load is 0. At this point, load is maximal, velocity is 0. So it is inversely related to the load. So initial length, maximum velocity. As the load increases, then the velocity. To work out when a muscle contracts against a load, it is W is equal to weight or work output is equal to load and the distance. Remodeling of the muscle. As you know, there is a relationship between the length and the tension, velocity and the load. So the forces developed inside the muscles are different in each situation, at different length and at preloaded condition or after loaded condition. So this is an important point to remember, that the remodeling of the muscle, they occur and match according to the function of the muscle. And all the muscles of the body are continually being remodeled. This is important. So you know very well, the belly or the biceps, they are more prominent in the porter because they have to lift the weight. Similarly, neck muscles are very stout in the porter. So this is the basis of the gym. This remodeling is important. Now, what it is? The diameter of the muscle fiber, length of the muscle fiber, and strength which develop inside the muscle fiber, and vascular supplies, they can be altered. This remodeling process is often quite rapid and can occur within few weeks. So in 4 to 6 weeks, 3 to 6 weeks, you can remodeling process can start in your muscles. So whenever there is only change in the diameter and length and strength, it is hypertrophy. And when there is a change in the vascular supply also along with the diameter, length and the strength, it is not hypertrophy, but it is hyperplasia. Now it's a very important slide where we will. So subscribe for further lectures in physiology by Dr. Kavita S Gupta if you like it. Thanking you.